Hello everyone, my name is Pivin Abram and in today's video we'll be talking about ray optics. Now ray optics is basically your first chapter of second book of class 12th physics, and this is under CBC board. As we are all aware that we are in the middle of pandemic crisis, so because of that the schools were a little bit affected. So because of that CBC has reduced the syllabus, so there are a lot of things or a lot of topics which has been reduced in this particular chapter. So we will be looking at that, and without wasting any more time, let's get started. Okay, so ray optics, in reality the name of the chapter is not ray optics, it is basically ray optics and optical instrument, but overall we just call it ray optics because it suits nice. I don't want to just write the entire screen with ray optics and optical instruments, but basically ray optics covers all those things. Okay, so let's get started. Okay, first of all, let's discuss what are the topics that we're going to study in this particular chapter. So there is an entire topic of reflection which is being deleted by CBC for this particular academic year. So there is a very big topic of reflection which is being cut out from this year's syllabus. Actually it was cut out last year also, but this year also it is not there. So we will start with refraction of light. That is our first topic. Then we'll talk about total internal reflection, although it is called reflection but it comes under your refraction topic. We'll talk about TIR, that is total internal reflection, and its applications. Some of its applications are mirage formation, sparkling of diamond, optical fiber. We will discuss all that in this particular topic. Then the next topic is refraction at spherical surfaces and lenses. How refraction happen on your spherical surfaces and also lenses. We'll discuss about that. Then the next topic is lens maker formula, very important as far as boards are concerned. We will talk about lens maker formula, and we will derive lens formula with the help of lens maker formula. We'll talk about magnification. What is the magnification of any particular refraction? Let's say for example, if you have a lens, so from your lens, let's say you are able to get an image, and how much that image is bigger or smaller as compared to that of your object. That is what the magnification is a measure of. So we'll discuss that. Next we have power of a lens. We'll talk about the power of a lens, right? Lenses that we wear has power, because for example, if you remember, all those people, or for example it may be you, that who is wearing lenses, so those lenses will be having some power, positive or negative. That is what we call as the power of the lens. So we'll talk about what is the power of lens, and we'll talk about how you can combine different lenses to increase the power, or you can just take out some layers of lens to reduce the power also. We'll discuss that, how you can add or increase the power, right? Next topic is refraction of light through a prism. We'll talk about prism and how refraction happen in prism. And finally we will discuss about optical instruments, right? So the optical instrument like microscope, astronomical telescope, reflecting and refracting, and we'll talk about their magnifying power or their magnification. So overall, when we see, although there are a lot of topics which is being deleted, but still it is a very huge chapter and very important one as far as your term 2 board examination is concerned, right? So your term 2 board examination will not be an objective type, as it will be most probably a subjective type. So we have to study all the derivations, we have to study all the concepts here, right? So let's start the chapter by the topic known as optics. Now optics is the core of this chapter, because what actually optics is, because in this in the starting it is saying ray optics. So basically the first and the most important question is what actually is optics, right? So what optics is, it's a branch of physics. So it's basically a part of physics that studies the behavior and properties of light. So basically we are talking about light. What are the different properties of light, how light behaves when you have different obstacles in its way. So all those studies comes under a branch of physics which we call as optics. All right, so as the topic says, ray optics, right? So basically optics means we are studying light, but ray means we are basically studying the ray aspect of your light. All right, okay, let's move forward. So basically, what is light? So like I said, optic, study of light. Now the next question is, what actually is light, right? So one of the easiest answer to this question is, light is basically a form of energy. It's basically one of the smallest form of energy. That is a very simple definition that you can make anybody to understand. So basically light is a form of energy which actually enable us to see, right? With the help of light we actually see. So when I talk about light, I'm talking about the visible part of entire enormous spectrum, right? Okay, now there is a lot of controversy. What is the nature of light? Is light a ray? Is it a wave? Is it a particle? There is a huge controversy. Although we got to know that light has wave and particle duality. That means sometimes light behave as wave, sometimes light behave as particle. But we still do not know exactly what is the true nature of light. So basically we just say it has a wave particle duality. But basically you have to understand, for some processes or some events light behaves, you can explain those events very nicely with the help of its particle nature, its ray nature. And for some phenomena it is very easier than, it is very easier to explain those phenomena with the help of the wave nature of light. So it is a matter of which scenario we are discussing. For example, if you are discussing about refraction of light, so it is very nicely suited if we can use the ray part of the light, right? We will assume that your light is basically a ray, right? We will not assume that your light is actually a wave. So basically we'll assume that your light is a ray, and then if we try to explain the phenomena such as your reflection, it becomes very easier for everyone to understand, right? On the other hand, if you make it a wave, it becomes tremendously difficult for it to understand, right? So that's why there are different aspects to it. So in a way, if somebody asks me what is a light, then you have to give me a situation what we are discussing here. For example, if you are discussing reflection, if you are discussing refraction, then yes, you will consider your light to be a ray, right? And if you are discussing phenomena like interference, phenomena like diffraction, right, then obviously you cannot explain them with the help of your ray or particle nature of light. You have to consider your light to be a wave. Then only you can able to explain those phenomena in a better way, right? So what is a light? It's a form of energy, simplest form of energy. Because of that, you can actually see the images that you can see in your mobile screen or in your laptop screen, right? So light is very important part of our life. All right, so for this chapter we will assume light as a ray. So we will solve all our problems considering light to be a ray. Now there will be some part where we will assume that light is kind of a wave. So there I will tell you, okay, at that time I'll tell you that we have to assume your light to be a wave, right? So basically you cannot just you cannot be stubborn that okay, light must be this or light must be that. See, light wants to behave as everything, right? So we have to consider that also. So light can behave as ray, wave, particle, whatever way you want to take it. But majorly in this particular chapter we will assume that your light is basically behaving as a ray, right? For this chapter there is important thing, light will travel in a straight line. We will say that light has a property which is like rectilinear property. Light propagates in a rectilinear fashion, right? So light travels in a straight line. So that is something which is true for this particular chapter. We will assume that light will always travel in a straight line, right? Okay, path of light, like I said, it will be a ray that is represented by this particular line and also the arrow. This is a ray, a single line with an arrow sign, right? Okay, a beam of light will be a combination of rays, right? So this is your first ray, second ray and third ray. A combination of all these rays is what you call as your beam of light. So you can simply say combination of more than two or more rays is what you call as your beam of light. Clear? All right, let's move forward. Yes, so basically like I said, reflection is not part of your syllabus, but without reflection we cannot get the feel of this topic. So let's dig into some of the basics of your reflection, right? Okay, let's start very quickly. I will not take much time here. So first of all, mirrors, because we have already studied these topics in our 10th standard, and that was in detail too, so I'm sure you must be remembering that. This will be just a small revision to what all things that we have studied in our 10th standard. All right, mirrors. Now mirror is something which we all love, right? We every day go in the morning and look how awful we look, but then we dress up, we change, we get ready, and then after getting ready we again look ourselves in mirror and we look so good, right? Okay, so mirror is again a very common thing. Everybody will be having some sort of mirror, but these days we use our front cameras of phones, so that is that, but still mirrors are still more significant this time. Okay, all right, so you guys can see this guy is very sad. I don't know why he's sad, but yeah. So what is happening in mirror? So mirror, reflection of light happens, right? So very quickly, let me just make a bulb here. Let's say you have a bulb over here. Yeah, bulb is there, so obviously the light is coming from the bulb. It strikes your face, and from your face it goes into the mirror, and from the mirror it comes back to your eyes, and that's how you can actually see. So basically there is a reflection that is happening, right? So because of reflection you're able to see yourself in the mirror, right? Okay, great. Now the important thing here is that image that is formed inside the mirror is a virtual image. It's basically a virtual image. It is not a real image, it is virtual image. Why it is virtual image? Because you cannot obtain that image on a screen, right? All right, so basically mirrors are of two types. Now what are those mirrors? They are of two types, simply plane mirrors and spherical mirrors. Then spherical mirrors is again further classified into concave and convex mirror. Now plane mirrors, so this is how you represent a mirror, right? This is a plane mirror, so you have a single line and then a polished side, right? So your reflecting side is this one and your polished side is this one. Next you have your concave mirror and convex mirror. So this is your concave mirror, right? So you can see this will be your reflecting side and this is your polished side. So next you have convex mirror. So in convex mirror the polished side is again inside and this bulging out will be your reflecting side. Is that a yes or no? Right? Okay, very quickly, if I make a principal axis here, yeah, so I have this principal axis. Okay, now concave mirror is what you call as your converging lens, or converging mirror, not lens. It's known as converging mirror. Why it is called converging mirror? Let's say very quickly, if this is the focus of the mirror, this is the center of curvature. So let's say there are like light rays which are coming parallel to the principal axis. They will converge at the focus, right? Something like this. Let's say light rays coming parallel to principal axis, they will converge. So no matter how many light rays come here, let's say two more light rays are coming, they all are going to converge at a single point, and that single point is what you call as your focus of that particular lens. So basically you can see all the rays, whatever rays that are coming, they're converging at a single point. That's why you call it converging mirror. I hope that's understandable. On the other hand, when I talk about your convex mirror, it is known as your diverging mirror. Now when I say, why I'm saying diverging mirror, very quickly let me just make the focus here, center of curvature here. Let's say the light rays are coming. So light rays are coming and it will seem like they are reflected back from, and the light rays, it will seem that they're coming from the focus, and all of them will be diverged out in different directions. If you see, they all will be diverged out in different direction, something like this. I hope you guys can understand. So these so they are diverging rays, they are not going to meet, right? That's why you call it diverging mirror, because what this mirror do is it diverges all of the rays which are like incident on it, right? I hope that is understandable. Now next thing, why it is called a spherical mirror, it's pretty simple. I'm sure you must have studied. Basically all these mirror are part of a big sphere, right? So it's basically part of a big sphere. that sphere will be having a center. That center is what you call as center of curvature. So basically what you do is you just cut two parts of this sphere, right? If you polish the outside part, this will become, concave mirror, right? And let's say if you polish the inside of the mirror, this will become convex mirror. I hope that is understandable, right? Okay, great. So that's why we call it spherical mirrors, right? Okay, let's move forward. Simple laws of reflection. I'm sure everybody will be knowing it, so I'll just very quickly let's discuss this. So you have a plane mirror here. So you have this incident ray. The moment the incident ray is incident on any, let's say, plane surface, and let me just say this is some point O. So the moment you see that there is an incident ray which is like incident on the plane surface or on a mirror, you immediately make the normal. Normal is basically perpendicular to that surface. Is that yes or no? And then according to our laws of reflection, that is your angle of incidence. Now what is your angle of incidence? It is the angle between your incident ray and your normal. This is your angle of incidence, right? Now according to laws of reflection, angle of incidence will always equal to angle of reflection. That means this reflection will be such that the angle of incidence will be repeated. For example, if angle of incidence is 30 degree, then angle of reflection must be 30 degree too. Then only it is going to follow your laws of reflection. And anyway, every reflecting surface follow this laws of reflection. You have to understand that, right? Okay, next law is that your incident ray, reflected ray, and your normal all lie in same plane. So I have written here angle. It is wrong. It is not angle. It's basically, let me just correct that, incident ray, reflected ray, and normal all lie in same plane. So basically you can understand here. So if I take it as a plane, so they all are in same plane. Yes, right. So you can consider, so for example, if this is your x y plane, so you guys can see your incident ray, your normal ray, sorry, not ray, normal to the surface, and your reflected ray all are lying in your x and y plane. So basically that is your law, right? So incident angle is equal to reflected angle, incident ray, reflected ray, normal all lie in the same plane, right? Okay, great. Next, very quickly, for example, let's say you have a concave mirror. So this line which passes through the pole or the center of your mirror, center of this particular mirror, is what you call as your principal axis, right? Okay, at the center, this is what you call as the pole, which is represented by the symbol P, right? Next you have F. F is what you call as the focus of this particular mirror, right? If you double it, you will get center of curvature. Center of curvature is basically the center. For example, if I complete this spherical mirror, the center of that sphere will be the center of curvature for that particular thing, right? Now very important, your focus, see this length is what you call as your focal length, which is represented by the symbol F, right? And the distance between the pole and the center of curvature is what you call as your radius of curvature, which is represented by the symbol R. Now these all things which we have studied in our 10th standard. This is just a revision, that's why I'm not going into details here, right? So you have to understand all the situations that we're going to, most of the situations that we're going to encounter. On all the situation, your focal length will be half of radius. That is, this length will be equal, these two lengths will be equal. Now there is conditions for, so this particular condition, that is your focal length is actually equals to r by 2. This is only true when your aperture is very small, right? And you have to understand your rays are paraxial. That means the rays are parallel. Mostly they should be parallel to your principal axis. Then only we can simply say that your radius is actually equal to twice of focus, or focus is actually equals, or focal length is actually equals to half of radius of curvature, right? Okay, let's move forward. Refraction. Now this is where we have to start. Refraction. Now refraction what is refraction? You guys can very nicely, see it from this image, right? We have studied somewhat refraction in our 10th standard, but let's try to, go into detail here. Now, refraction, you guys can see this image. You guys can see there is this pencil which is like kept inside a glass of transparent, we have a transparent glass, and inside that glass we have poured some water, and simply we just put a pencil over here, and you guys can see the pencil is distorted. Is it distorted? Yes. You guys can see it is like, it feels like the pencil is being cut over here, and half part is here and then half part is up. So this is how you can see. So why this is happening, why there is a distortion in the image? This is because of refraction of light. The light that is coming, or the light which is like we are able to see, is being refracted, right? Okay, now let's try to understand what is this refraction. According to definition, what is refraction? Changing or deviation of a ray of light when it enters a different medium. So basically, if we are changing the medium, then there is a bending or deviation of the ray of light because of the different speeds here, right? So for example, here you guys can see we are changing the medium, right? There is air, there is glass, there is water, so there are different mediums here, right? Because of the changing of medium, you guys can see there is something, something weird happening here. Because of that, you can see the pencil is being distorted, right? Okay, now we have to understand what actually is a medium. Now, medium can be anything. For example, water is basically a medium. You can say water is a medium. Yes. Air is a medium. Yes. Vacuum is also a medium, right? So water, air, vacuum is a medium where there is nothing there, right? It's basically, you can say there is nothing there, a medium of nothingness, right? Air is a medium where there is a lot of air molecules, air particles. Water has water molecules as their medium, right? So these are different mediums, right? I hope you guys can understand. For example, if you want to speak something, you want to be in air medium. For example, if you are in water, you want to speak something, it becomes very difficult, right? Because there are a lot of water already going inside your mouth, right? So if you want to talk something, you want to be in air medium. In vacuum also, you cannot speak anything because there are no air molecules or air particles to transfer whatever you want to talk to further distances. So in vacuum also, you will not be able to say something. Air is a very nice medium where which you can actually talk, right? On the other hand, you have to understand there is something known as optically rarer and denser medium. Now, what do we mean by rarer and denser medium? So you have to understand whenever we compare different mediums, there is something known as denser medium, there is something known as rarer medium. Now, this denser and rarer medium, the concept of denser and rarer medium can only be understood when you compare any two medium. For example, you have water, you have air. So you are basically comparing these two mediums. So you are comparing, okay, how the light is going to behave in water and how the light is going to behave in air. So the moment we compare, so you have to consider one medium to be denser, one medium to be rarer. Let's take an example and try to understand this. For example, let's say we have two mediums. So let's say here we have air particles and there is an interface. So this is your interface. Interface, let me just write it here, interface. Now what is this interface? Interface is a place where basically your mediums are separated. So you have so above this particular point you have air and below this you have water. So you have two mediums here, air and water, right? Okay. Now let's try to understand what do we mean by optically rarer medium and optically denser medium. Let's say we have a light, we have a ray of light which is like traveling like this. So this is your incident ray, and this incident ray is incident on the interface at point A, right? Okay, so it is incident on point A. All right, the moment we observe that there is a ray which is incident on this particular interface, next step is we will very quickly make the normal. So normal is very similarly same. It is perpendicular to the surface, right? So we have made the normal. So the angle between your incident ray and the normal is what you call as your angle of incidence. Yes, it's pretty simple here, right? But you have to understand now what is happening here. The light ray is going from air to water, right? The light ray is going from air to water, right? Now optically rarer medium, optically denser medium. Denser medium means a medium which is dense in nature. Rarer medium means it is not so dense in nature. So you just tell me, from air and water, which medium feels denser in nature? Yes, I hope you guys have guessed the answer. Naturally, we will say that okay, air seems rarer because it is not so dense. On the other hand, water, because you can simply do simple experiment. Tell me, which is easy, waving hand in air or waving your hand in water, right? So when you're waving your hand in water, it requires some effort, but on the other hand, when you're waving your hand in air, it does not require that much of effort. Yes, right? So you can simply say from this simple experiment that yes, air is somewhat no, I should not say somewhat, but it's basically very rarer as compared to that of your water. Water is denser in nature, right? So let me very just quickly just write that down. From a simple experiment, we can say okay, this air is basically rarer and this is denser, right? Now again, this rarer and denser concept can only come when we are comparing mediums. So right now I am comparing my air with water. That's why I'm saying air is rarer and water is denser. All right, so we have this incident light, right? Incident ray, which is like incident point A. Now we're entering rarer to denser medium, right? So this is the property of your optically denser medium. So basically what is happening, so light is basically traveling here, right? So as the light is traveling from a rarer to denser medium, the speed of light is going to be affected here, right? Because right now water is a denser medium, right? So what is going to happen whenever this happens, whenever light is traveling from rarer to denser medium, it is going to bend towards the normal, right? So in reality, what is going to happen, it should go like this, right? It should go, if there was no medium change, it should have gone like this. But in reality, as the light is traveling from your rarer to denser medium, it is going to bend towards the normal, right? So this is your refracted ray, refracted ray, and you call this angle of refraction, right? The angle between your normal and the refracted ray, you call this angle of refraction, right? So basically what happened, so what is an optically denser medium? If somebody asks you what is optically denser medium, first of all, if your light ray is traveling from rarer to denser medium, then in optical denser medium, light ray will be refracted towards the normal. When this happens, we can say okay, this medium is optically denser as compared to that of your other medium, right? Okay, let's take one more example here. Now this time you have again two different mediums. Again, you have water here and you have air. So here you have interface. This is my interface, right? All right, this is my interface. And again, let's say this same ray is again incident on this new interface. Let me call this point B. So it is incident here. Very quickly, the moment you see the incident at the interface, you make the normal, and let's say this is my incident ray for this particular interface, right? Okay, great. Now you have to understand, you have air and you have water. Now you tell me, when I compare here, which one is rarer, which one is denser? Yeah, obviously this is rarer and again this will be denser, right? Okay, now you have to see your light ray is traveling from denser to rarer medium. The moment, so obviously light ray will be having some difficulty in traveling, or the speed of light ray will be changed over here, but it is going towards the rarer medium. The moment it goes to a rarer medium, the speed of light will be automatically increased, right? So whenever light is traveling or light ray is traveling from denser to rarer medium, it is going to bend away from the normal, right? It is going to bend away from the normal. Let me call this angle of refraction for this particular case, right? I hope that is understandable. So if somebody asks you what is your optically rarer medium, you will simply say, so if your light ray is traveling from denser to rarer medium, then if the light ray is bending away from the normal, then that medium is what you call as your optically rarer medium with respect to other medium. I hope the concept is clear to you, right? So again, very quickly, let me make you guys understand. Let's say you have this interface. Let's say here you have rarer medium and here you have denser medium. So very quickly, you have to understand, let's say light ray is coming from rarer to denser, you want to go. So this is your angle of incidence. So when you're going to denser medium from the rarer medium, light ray is going to bend towards the normal, right? It is going to bend towards normal. Again, let me just, it is going to bend towards the normal, right? Okay, again, bend towards the normal, something like that. It is going to bend towards the normal. And very similarly, if we are going from denser to rarer medium, what is going to happen? This is my, let's say, incident ray, right? And we're going from denser to rarer, it is going to bend away from the normal, right? So this is your angle of refraction, right? So this is something very important for you all to understand. Clear? Okay, let's move forward very quickly. Okay, just like your laws of reflection, we have our laws of refraction, right? Okay, so you have this interface here. Let me say this here, interface, everything is set. We have, medium one. We have two different mediums here. I haven't said which medium it is, so just assume we have two different mediums, medium one, medium two. The information that is given to us, that medium one is rarer as compared to medium two, right? So medium one is rarer medium as compared to your medium 2, which is like denser medium, right? Okay, all right. So let's say you have an incident ray here. So I have this incident ray, and which is like incident at, let's say, point A. The moment you make the incident ray, okay, the next step is make the normal. Yes, very quickly make the normal. This is your angle of incidence, right? So now you have to tell me, we are traveling from rarer to denser medium. The moment we are traveling from rarer to denser medium, what is going to happen to the light ray? Yes, we are traveling from rarer to denser medium. Just in the previous slide, we just understood, if your light ray is traveling from rarer to denser medium, it is going to bend towards the normal, right? It is going to bend towards the normal, right? Okay, so very quickly, let me just make it, so the angle between your incident ray and the normal is what you call as your angle of incidence, and the angle between your normal and your reflected ray is what you call as your angle of refraction, right? Okay, now let's try to understand what is your law of refraction. First law of refraction, which is also known as Snell's law. This is what you call as your Snell's law also. So in exam, if the question paper is asking about Snell's law, don't get panic. It's basically talking about laws of refraction, right? Okay, first law says that the ratio of sine of angle of incidence to the sine of angle of refraction is equal to a constant which is equal to refractive index of second medium with respect to the first medium. Okay, so it is saying the ratio of sine of angle of incidence. So the ratio of sine of angle of incidence, sine I, to the ratio of sine angle of the ratio of sine of the ratio of sine of angle of incidence to the ratio of angle of refraction, to the ratio of sine of angle of refraction, that is sine of angle I upon sine of angle R. This is something which the statement is saying, that is the ratio of sine of angle of incidence to the sine of angle of refraction is equal to a constant which is equal to refractive index of second medium with respect to first medium. So it's basically is equal to a constant which is known as refractive index of second medium upon refractive index of first medium, right? So this is what it is telling you, right? So this is how it is written: sin I upon sin r, sin I upon sin r is actually equals to nu2 upon nu1. So basically this symbol is what you call as nu. Nu is for your refractive index, right? And this entire thing is what you call as your Snell's law. Now what is your refractive index? We'll try to understand this in a bit, but you have to understand what is your first law. The sine of angle of incidence upon the sine of angle of refraction is actually equal to a constant, and this constant is what you call as a refractive index of second medium with respect to refractive index of first medium. Now we'll try to understand, and you can represent it by nu21 also, right? So basically sin I upon sin r is refractive index of second upon refractive index of 1, or you can write it nu21, right? So if you want to write it, if you want to write it, so for example, certain nu1 upon nu2, nu1 upon nu2 will be equal to sin r upon sin I, right? That is how it will be written, right? I hope that is understand, right? Now the important question: what is this refractive index? What it tells us, right? Okay. Now refractive index is a measure of how dense a medium is, right? So for example, it is the property of the medium here. For example, let's say you have a medium. Let's say you have this interface. You have medium 1, you have medium 2, right? Now let's say medium 1 has some refractive index of, let's say, 1, and medium 2 has some refractive index of 2, just for an example. So the medium, you have to understand, the medium which has more value of refractive index will be optically denser medium, right? So it becomes, so it basically, with the help of refractive index, you can tell which medium is optically denser and which medium is optically rarer, right? So if the value of refractive index is more for a particular medium, then that medium is more dense. So for example, here medium 2 is denser than medium 1. Yes or no? For example, let's say you have a medium, you have medium 1, you have medium 2, and let's say if medium 1 has a refractive index of 0.3 and medium 2 has a refractive index of 0.1. Now you tell me which medium is, optically denser. Yes, if you have guessed it, this one, that is right. New one, that is medium 1 will be optically denser as compared to your medium 2. So what is this Snell's law telling you? That is sine of angle of incidence upon sine of angle of refraction is basically equals to a constant that will tell you that how much bending will be happening based upon the refractive index, right? So this is how you can write it. So how I write it, it's I don't want to just remember this thing. So how I write it here, so whenever you see this image, you just see, okay, let's say your medium 1 has some refractive index of nu1 and medium 2 has some refractive index of nu2. So how I'm going to do here, I'm going to write it here. I will see, okay, nu1 times of sine of angle I, right? This is how I'll write nu1 times of sine of angle I, and that will be equal to, yes, next one here is nu2 times of sine of angle r. That will be equal to nu2 times of sine of angle r. So this is how I like to write it, right? I like to prefer writing it, right? So this actually means the same thing. See, you can simply see sine I upon sine r will be equals to nu2 upon nu1. The same thing is happening, but you don't have to remember it. You just see, okay, nu1 has the refractive index, the medium 1 has nu1 refractive index, medium 2 has nu2 refractive index. Then by Snell's law, this is also known as your Snell's law. So by Snell's law, you can write, okay, I can write nu1 times sine of angle of incidence is actually equals to nu2 times sine of angle of refraction. Very easy, very simple, right? I hope that is understandable. Yes, okay, let's move forward, right? Okay, so that is what is your refractive index. Now there is something known as absolute refractive index of a medium, right? So here you are basically comparing a refractive index, right? Refractive index of second medium with respect to first medium. Now if you want to find out the absolute value of a particular refractive index, how you can find that out? Okay, let's discuss that. So you can find that out. It is the ratio of velocity of light in vacuum to the velocity of light in medium, right? So if you want to find out your absolute refractive index of a medium, then you have to compare it with the vacuum, right? For example, let's say if a light ray is traveling in vacuum, you have to understand the light ray which is traveling in vacuum, that means there is no presence of medium is not there, right? There is nothingness, right? That means there will be no obstacle for the light to overcome. That means light will be at its fastest, right? That means it will be traveling with the speed of light, that is c, that is equal to 3 into 10 to the power 8 meter per second. So light will be traveling with this high speed. Is that a yes or no? I hope that is understandable, right? Okay, so light will be traveling the fastest, that is traveling with c. Okay, it is incident at an interface. Okay, it is incident at an interface. Let me say incident at some a. The moment it is done, you just simply make a normal, right? This is your angle of incidence. So we are going from, okay, vacuum will be the rarest medium, right? This is your rarer medium, and medium will have some, it will be denser as compared to vacuum, because obviously if you take air also, air will have air particles, so it will be denser as compared to that of your vacuum. So this is your denser medium. So we are traveling from rarer to denser medium. That means your light ray is going to bend towards the normal. Yes or no? So it is bending towards the normal, and this will be your angle of refraction. But you have to understand the speed of light is now changed. It is not same as c. So let's say the speed of light is some v here, right? Okay, now you have to understand when it was traveling in vacuum, the speed was c, that is it was traveling with the maximum speed. The moment we have jumped from your vacuum to denser, the speed is now changed. Now what is this absolute refractive index of the medium? That means I want to find out what is the absolute refractive index of this particular medium. So it is the ratio of velocity of light in vacuum to the velocity of light in any particular medium. So what is it? So refractive index of my medium is the ratio of velocity of light in vacuum. So vacuum, the velocity of light is c, and in that medium, let's say the velocity of light is v. So this is the absolute refractive index of this particular medium, right? I hope that is understandable. Very similarly, if you want to find out refractive index relatively, right? So again, this helps us to give me a formula which actually relates the refractive index with the speed of light. So for example, let's say you have two different medium. Let's say you have first medium, you have second medium, right? And let's say you have, this is your normal incident ray, right? Let's say this is your rarer medium, denser medium, right? So we are going from rarer to denser. That means light ray will bend towards the normal. So in this one we will having some velocity v1, this will be having velocity v2. This is your angle of incidence, this is your angle of refraction. So let's say this one has some refractive index nu1, this one has some refractive index nu2. So from this you can simply say the refractive index of second medium, that is this one, with respect to your first medium, can also be written as speed of light in your first medium upon speed of light in your second medium. There is one more formula here. I hope you guys can understand that. Yes. So again, if you want to find out absolute refractive index of a medium, then you have to compare it with the vacuum, right? With the vacuum being the first medium, and whichever medium you want to find out the value of your refractive index, that medium is the second medium, right? For example, if I want to find out the absolute refractive index of water, then here it will be water and here it will be vacuum. Yes, right? And then okay, light ray is coming and it is bending, and then what you will do if you want to find out absolute refractive index of water, that is c upon velocity of light in water. This is how you can find it. I hope that is understandable. Yes. Okay, cool. So if that is true, let's do some numericals so that we can know, okay, that you understood whatever we have studied in this particular lecture. Okay, first question. Very quickly, speed of light in air is 3 into 10 to the power 8 meter per second. Okay, great. And speed of light in glass is 2 into 10 to the power 8 meter per second. Okay, the refractive index of glasses. So basically we have air and glass as a medium. So I'll just make the diagram. Air, and you have next one as glass, right? So you have two mediums here, right? So obviously by the look of it we know air is your rarer medium and glass is my denser medium, optically denser medium, right? So you have your light ray incident at point A. After incident you very quickly make the normal, right? And then as we are traveling from rare to denser medium, light is going to bend towards the normal. Yes or no? Right? Okay, this is your angle of incidence, this is your angle of refraction. Is that a yes or no? Right. Okay, great. Now in the question it is given that speed of light in air is given to you, right? So this value v1 and v2 value, let's say v1 is the speed of light in air and v2 is the speed of light in glass. Now this is something which is given. Speed of light in air is given, that is speed of your light 3 into 10 to the power 8 meter per second, and speed of light in glass is given to, that is 2 into 10 to the power 8 meter per second. As you can see, it is being reduced, and that should be the case. Then you can simply say, and you're supposed to find a refractive index of glass. Now refractive index of glass you have to find, that is refractive index of glass with respect to air we will be finding out. So that will be given as, yes, speed of light in first medium, or I can simply speed of light in air upon speed of light in glass. The speed of light in air is given to us 3 into 10 to the power 8 upon, in glass it is 2 into 10 to the power 8. This will cancel out. Refractive index of glass with respect to air is coming out to be 3 by 2, or that will be equal to 1.5. Now you have to understand, refractive index is basically ratio of velocities. Can you guys see that? Refractive index is basically a ratio of velocities, right? So in numerator and denominator we both have velocities. So you tell me, will refractive index will be having any kind of units? No, basically it's basically a ratio. So it's a unit less quantity, right? So do not write any unit in front of your refractive index, right? Okay, great. So refractive index of your glass is coming out to be 1.5. Okay, I hope that is understandable. Let's move to the next question. Index of glass is 1.5 and refractive index of water is 1.33. All right. So when I say refractive index of glass, that means we're talking about absolute refractive index. That is, it is being with respect to vacuum. And refractive index of water is 1.3. That means we're talking about refractive index of water with respect to vacuum, right? Okay. With that being said, what is the refractive index of glass with respect to water? Now that is simply, we are supposed to find out refractive index of glass with respect to water. Okay, very quickly let's do. So refractive index of glass is given to us, and this is with respect to vacuum, and that is 1.5, and this can be also written as speed of light in vacuum upon speed of light in glass. Let's say speed of light in glass is Vg, right? Okay, all right. Next, refractive index of water with respect to vacuum is given to you, that is 1.33, and that is also equal to speed of light in vacuum upon speed of light in water. Yes or no? Okay, now according to the question is asking refractive index of glass with respect to water. That means here you have glass and here you have water. So this is your medium 1, this is your medium 2, right? So obviously light would have been coming. So refractive index of glass with respect to water means speed of light in water upon speed of light in glass. This is something which we are supposed to find out, right? And we can very easily find that out by simply, let's say this is my equation number 2, equation number 3, sorry, equation number 1, equation number 2. Simply divide equation number 1 by 2. So when you divide it, very simply you will get refractive index of G with respect to vacuum, refractive index of water with respect to vacuum, and you will see here C upon Vg multiplied by velocity of light in velocity of light in water upon c, and this will cancel out. You will get vw upon vg, which is basically is what required, right? Now all we have to do is divide, right? Now which quantity we have to divide? You have to divide refractive index of glass with respect to vacuum upon refractive index of water with respect to vacuum. Now these values are given to you. This is your 1.5 and this is your 1.33. All right, so take out, so this will be also equal to, here this will be 1510, and this will be equal to, okay, very quickly this will be, okay, this will be, take out the 0 here, here this will be 1520, and here 133, and this 10. So this will be the case. This will be 150 upon 133, will be the refractive index of glass with respect to water, right? Okay, next one is refractive index of water with respect to glass. So refractive index of water with respect to glass will be reciprocal of this. This is 133 upon 150. I hope that is understandable, right? So it will be simply reciprocal of the first one. Okay, let's move to the next one. Question number third. Question number third says the refractive index of 4 media, that is A, B, C and D, are given in the following table. So you have medium A, medium B, medium C, medium D, and refractive indexes are given in the following table. The question is pretty simple. Question is, let me just write the question here. The question is that which two medium will have the velocity of light or the bending maximum? Let me just write that down. In which two mediums the velocity, or I can say the bending of light will be maximum. The bending of light will be maximum, right? And in which two medium it will be minimum? In which two medium it will be minimum? So you can see here in which two medium the bending of light will be maximum. Now first let's answer that. In which two medium? So basically we can simply see, the more the value of refractive index, more denser the medium, right? So this medium is a densest medium, 2.40, and this is the rarest medium, right? So if I take medium A and medium B, right? If I take medium A and medium D, you tell me light will be bending very sharply towards the normal because there's a huge change in the densities of the medium. Can you guys see that? So refractive index is very different here. It is 1.33, it is 2.40. So I can simply say the maximum bending will happen if, so let me say maximum bending we can see when I take medium A with respect to medium B, with respect to medium D. Is that a yes or no? Now let's talk about the minimum. So minimum, you guys can see, if you very nicely look here, medium B and medium C, they have very few, you know, the difference is very small. This is 1.5, this is 1.52, right? So from here we can say minimum bending will happen in your B with respect to C. I hope that is understandable, right? Minimum bending will happen in your B and C, right? Okay, great. Let's move to our last question. That is, if a ray is refracted at an angle of 30 degree and the refractive index is 2/3, complete the angle of incidence. All right, okay, compute the angle of incidence. So basically you have a ray which is refracted at an angle of 30 degree and refractive index is also given to you. All right, great. So very quickly, let's say I have this interface, right? And refractive index is given to you, right? And compute the angle of incidence. All right, so I will not waste my time here. I will simply apply my Snell's law, that is sine of angle of incidence upon sine of angle of refraction will be a constant, which is like given to you, right? So sine of angle of incidence, now you have to see your angle of incidence is something which you have to find out, which is not given to me, but angle of refraction is given to me, that is 30 degree. So r is given to you 30 degree, so this is your sine of 30 degree. All right, great. And your refractive index is given to you, that is 2 by 3. Okay, so you have to find out angle of incidence. Now sine I, okay, what is the value of sine 30? For all those who do not know, value of sine 30 is half, right? And that is equals to 2 by 3. So sine I will be equals to 2 by 3 multiplied by 1 by 2. So this is, this is half and half cancel out. Sine I is coming out to be 1 by 3, or simply your angle I will be equal to sine inverse 1 by 3. Yes, so that is the answer. I hope that is understandable. I hope the entire video is very useful to you. If you have any doubt, you can comment it down in the comment section. And that's all for today. Thank you and have a nice day.